Okay, guys, I thought we'll switch it up and do it like this since I'm at school still. Here is our 6.11 and 6.12 homework, all right? We're going to fill in the blank to complete the equation so that x equals 2 is a solution over here, okay? So remember, the simplest way to solve an exponential equation is if we can make these bases match, all right? So whenever I see 10, that's my lucky day, because all I gotta do is count zeros. 1, 2, 3, 4, 5, 6. I can write this as 10 to the something x equals 10 to the 6th, okay? Because a million is 10 to the 6th power. And now, that looks like a negative. I don't love that. So I'm gonna make it a box like it was. Now, since the 10s already match, if I just make whatever number goes in here, it's like super weird to me that it's a box, you guys. It's throwing me off. I don't like it. I'm gonna call it A, all right? If I just have A times X equals 6, then I'm golden, all right? This equation is perfectly equal on both sides. Okay, so what do they want here? Because I got two variables. Can't solve for 2. Earlier, they told me they want x to end up equaling 2. So I'm gonna replace that x with 2. So this is 2 times A equals 6, which means divide both sides by 2, A is 3, okay? So right here, okay? Easy peasy, all right? Let's keep going. Okay, we're still trying to make the equation be 2. So we have, okay, this time I'm gonna save myself the trouble and plug the 2 in from the start, all right? You live and you learn, you guys. So this is 10 to the power of 2 times 2, which is 4, plus something equals something. And it seems like I have a lot of freedom with these two somethings, you guys. 10 to the 4th is a 1 with 4 zeros. 10,000. 10,000 plus something equals something. Just make it equal and we're good. I don't know, you could put a 1 right there, as long as you make this 10,001, because 10,000 plus 1 is 10,001. Put a 5 and make that 10,005. Put a 10,000 and make this 20,000, all right? The possibilities are endless. Okay. Oh my gosh, we're still doing this. Okay, let's keep going. We want x to end up being 2. So let's go ahead and drop it in right there. I want something times 10 squared to equal something, all right? 10 squared is 100. So I want 100 times something to equal something. And again, you guys, the liberties here are insane, all right? They didn't even say 2 be the only solution. So I'm even thinking you put a 0 right here, because 0 times 100 equals 0, okay? And it actually wouldn't have mattered what x was. Anything would have worked. You can put 5 right here. As long as 5 times 100, you put 500 right there, all right? Go with negative numbers, go with fractions, go whatever you want, all right? Okay, we are gonna keep filling in the blank so that 2 is a solution, all right? I'm gonna drop this 2 in. I have log. I always like to know what my base of my log is, you guys. So the base here is 10, log base 10 of something. I'm assuming this is times. Something times 2. So let's call it 2 times something. Let's just call it A. I'm gonna call this A, you guys. the box is weird. Equals 3. All right, now we're talking. Now I got myself something I'm trying to solve for that's inside a log, all right? So a great strategy to get to my variable is to change the form from logarithmic form. Let's change it into exponential form, all right? So this same exact thing right here, it can be written as an exponential equation instead. Here's what it would look like. It would have the same base of 10. So it would be 10 to the power of, it would be 10 to the power of 3 equals 2a. All right? That's how we change this into an equivalent equation, okay? Just in a different form. For a little while, you guys, while I was getting used to this and getting comfortable with this, my go-to was log base 2 of 8 equals 3. I knew log base 2 of 8 was 3, and I knew 2 to the third is 8. Okay? So I would just put this in the corner of my paper, and whenever I was trying to figure out where these things go when they switch between these forms, I would just use that as a reference, okay? Anywho, it also helps to remember the base stays the base. The base of the log will stay the base of the exponent. At this point, 10 to the third power, that's 1,000. So once I divide both sides by 2, I know that A has got to be 500. So up here, we wanted a 500 in the box in order to make 2 a solution. Okay. So keep the fun going and look at number 6. Determine the value of A for this equation. All right, you guys, look at this. This equation has what I like to think of as fluff, all right? That's 6 times blah, 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 right? The real work is over here. This 6 times my real work, that's fluff. It's fluff I don't need. So what I would like to do is divide both sides by 6 and get rid of that fluff, all right? I end up with e to the a plus 1 equals 1, all right? Now you guys, I would say that there are 2 reasonable ways to solve this, okay? The easier way is a little harder to see, but I will show it to you. This is the easier way. You're saying that e to some power has to equal 1. And when we can make these bases the same, it's the easiest way to do it. So the question is, can I write 1 as a base of e? And if that 1 were any number other than 1, I would say probably not. However, anything to the 0 power is 1, all right? So you could write the 1 as e to the 0, and now you have the bases matching, so you just need your exponents to match. A plus 1 equals 0. That makes a negative 1, all right? Okay. Simpler, maybe tricky to see. So let's look at another option, okay? The other option is to say, okay, I can't make the bases the same. And my variable is in the exponent. So I'm gonna switch forms. This is an exponential equation. I'm gonna rewrite it as a logarithmic equation. So I'm gonna write a log with the same base, e, of 1 equals a plus 1, okay? Now log base e is shorthanded as ln, so this is the same as ln of 1 equals a plus 1. And you guys, with experience, I hope that you will look at any log of 1, ln of 1 or log base anything of 1, and know that that's 0, all right? Because of this property, right? E to what power is 1? 0. 5 to what power is 1? 0. 10 to what power is 1? 0. Anything to what power is 1? 0. So with experience, you'll see that, all right? I hope you see that. But you can also check it real quick with your calculator. ln1, press enter, it's 0. There we have it. Subtract the 1 from both sides, and a is -1, just like it was over here, okay? All right. Okay, more fun. Let's keep it going. 2 to the 5a equals 100, all right? Now, the first question you might have is, can I write 100 as a base of 2? And the answer to that is no, but you could definitely check with your calculator, all right? If you check and you just try 2 to a few exponents, you'll eventually see that 2 to the 6th power is 64, and that 2 to the 7th power is 128. So we skip right past 100. There's no nice power of 2 that we can write 100 as. So because of that, I'm just going to switch this into a logarithmic equation right off the bat, all right? We're gonna go log. You guys, please know you cannot divide both sides by 2. You cannot divide both sides by 5. You can't do any of that. Your variable's in the exponent. This is a serious situation, all right? This is not 2 times 5a equals 100. If it was, then you could divide 2, then you could divide 5, but that is not what we have, all right? Okay. Log with the same base of 2 of 100 equals 5a. And now, log base 2 of 100, you guys, is a number, all right? It's not a very nice number. It's not an easy number. It's not a rational number, but it is a number. And in the math world, we are perfectly comfortable leaving it this way, all right? So we're perfectly comfortable not touching that at all. Leave it be, log base 2 of 100. However, I know some of us might be uncomfortable, and we might come off to the side and do the change of base formula to say that log of 100 divided by log of 2 is equal to that. And then we go to our calculator to get that this is about 6.6. So some of you might say, okay, this is 6.6 equals 5a, and then you'll divide both sides by 5, and you'll get that a equals 6.6 divided by 5, which is 1.33. Approximately. All of this is approximately at this point, because we rounded, all right? Now, I told you guys in class today that I challenge you not to be afraid of log base 2 of 100, because that's just a number. What you could have done is said, that's just a number, and I'm still trying to solve for a, and 5 is what's really in the way right now, not that log. So I'm going to divide both sides by 5. And you would have gotten log base 2 of 100 divided by 5 equals a. All right? And that's it. This is okay. This is an unrounded answer, all right? So, you guys, I prefer this guy right here. But this guy is also usually acceptable. Okay. All right. Okay. Now we have another one. We have some fun. We have a 1/4 in front of our real work. So let's first get rid of that 1/4. We could do that by multiplying both sides by 4. All right? It will cancel out right there, leaving me with 10 to the 2a equals. And over here, you guys, this 4 and that 40,000 can cross cancel to leave me with 1 over 10,000. All right? You could have also multiplied across, put the 4 over 1, multiply across. I know a lot of you guys prefer it that way. So then you would have gotten 4 divided by 40,000, which you then could reduce to that. Okay, here I am. 10,000 is 10 to the 4th. So 1 over 10,000, 10 to the negative 4th. And now look at this, my bases match. So I just need 2a to equal negative 4. So that means a is negative 2. Okay. All right. What else do we have here? We have this situation. Okay, again, some fluff. Let's start by subtracting that 21 from both sides. We get e to the 1/4 a equals 30. And now we can rewrite this, all right? Because my variable is in the exponent. My e and 30 are never gonna match. So what you can do is just turn this into an exponential, like I showed you on a previous problem. Log base e of 30 equals 1/4 a, and log base e is ln, right? The reason I'm doing this off to the side, I want to show you something different, all right? You can totally do it this way, and you'll get the same answer. But I just want to show you what I think of this as. I think of this as an e that I want to get rid of so that I can get my exponent all alone. And the way that I imagine, the way that I can get rid of an exponential base of e is with ln. ln cancels e out. So I think of this as lning both sides, taking the natural log of both sides. You can do whatever you want as long as you do it to both sides of the equation. And here, ln and e cancel out. So I get 1/4 a equals ln of 30, which is the same as that, okay? Two different ways to see it, do it, whatever you want. And now, almost done here. Let's just multiply both sides by 4. I prefer to write my times 4 in front of the log instead of at the end, because ln of 30 times 4 is not ln of 120, but it's an easy mistake to make when it's written like that. So I just put it like this. And I get a equals 4 ln of 30. Done. If you absolutely must go to your calculator and get a decimal approximation, go for it, but I don't see the point. Okie doke. All right, here we go. Which of the following equations is equivalent to 10 to the 3x equals 150? Oh, this looks like an SAT problem, doesn't it? This looks so SAT, I just got a flashback. Okay, let's do it. Could it possibly be the same as 2 to the 3x equals 150? I honestly don't even know what they were thinking with that one. How could 10 to the 3x equals 150 be the same as 2 to the 3x equals 150? It can't be the same. So I'm anti any of those choices that have 1 in it. Okay, let's look at 2. 2 says 3x equals log of 150. There might be merit here. Let's see. Can we see what this is as an exponential, please? It would be a log base 10, which I don't have to write if it's 10, of 150 equals 3x. Oof, that's totally that. All right, so 2, check. 2 is good. Oh wait, not 2 only, but like 2 is good. All right. What is up here? What did they do here? No. This is not good. Yes, I don't exactly know what they were thinking here. But I think the easiest way to explain this one is, let's look at it. 1/3 log of 10 equals 150x. I mean, okay, so log of 10, this is log base 10 of 10. This cancels out, leaving us with just 1. This is 1/3 equals 150x. It's just not the same. I'm not sure what they were thinking here. I'm trying to see what logically they were thinking. X, I don't know. It's not the same. You know, this is not it. It's 2 only. Okay. Number 10, using the numbers 1 to 9 only once, fill in the blanks to write an equation that gets the largest solution possible for x. Okay. Let's see what we got. Whew. I'm always a little anxious when I see these problems, you guys. So we want x to be as large as possible. And I can use these numbers once only. Okay. 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 So I want log base 2 of something times ln of something x plus 3 plus log base 3 of something to be a 2-digit number. And I want x to end up being the biggest possible thing. So here's my logic, you guys. I think the biggest possible thing would be to have the biggest possible, to have all of this equal the biggest possible thing. That's just kind of what I'm thinking. So I'm thinking I would want like 98 over there. I could be wrong. When it plays out, we'll find out. But I'm thinking the biggest possible thing would be trying to get a 98 over there. But then these are all integers, and this needs to come out nice. So how is ln of something x going to come out nice? Ln of none of those things will come out nice. That's a good one. Or is it a good one? I don't know. Because okay, wait, I'm re-strategizing now, you guys. According to this being just a 2-digit number, i.e. an integer, then I need things on this side to work out nicer. So log base 3 could be of 3, log base 2 could be of 2 or 4. In order to come out to be an integer. And if I don't put 98 here, this could be 3 or 9. So if it's log base 3 of 3, this is 1. If it's log base 3 of 9, it's 2. Over here, if it's log base 2 of 2, this is 1. And if it's log base 2 of 4, oh, if 8 is free game, I could also have 8 right there. And this could be 3 times ln of something x plus log base 3 of 9, which is 2. But well, how is ln of something x going to come out to be an integer? I don't think it ever will. Let's check. Let's check, because I don't know what's going on here. Am I seeing this wrong? Or are they kind of wrong? This is 611. Ooh, how did I scroll all the way to 6-1? 6-9. 6-1, 611. No, they... Silly me. X doesn't have to be an integer. Okay, all right, I just looked at the answer. I kind of cheated. I got thrown off by the fact that this had to be an integer, but X doesn't have to be an integer. So it looks like my original strategy of making this come out to be the biggest number that it can be, which is 98, was the way to go. And then now, if we want this to be 98, in order for X to be the largest it can be, we want to make X do all the heavy lifting to get this side of the equation to be big enough to come out to 98. So that means we want to give these guys as little to do as possible, all right? The one that I want to help the least is that box. I want X to do all the work. So I'm going to put my smallest possible number that I can right there. And then the next smallest numbers are going to have to go here and here, all right? So like 2 and 3 have to go here and here. But how would they make the smallest possible thing they can? If I put a 3 here, this would become a value bigger than 1. So it would take a little bit of the work away from X. So I'm thinking we should leave this to be as small as possible, leave that to be as small as possible. Ooh. And then now it's gonna have to be X that like really is as big as possible to get us to 98, all right? Okay, sorry, I went around in a circle. I should have stuck with my original thought. Okay, and then lastly, we're gonna do a little spiral review. So an investor deposits $3,300 in a bank account that earns 4.2% interest annually. If T represents the number of years, write a function that models it when it is compounded monthly. All right, you guys. When we're compounding anything other than continuously, we'll always begin with our starting amount. But then we'll have to multiply it by 1 plus our rate, which is 0.042. But if I'm compounding monthly, then I'm gonna get 1/12 of that each month. So then I have to divide that rate by 12. And then I have to raise it to the power of how many times I get paid. And how many times I'll get paid is T being the number of years, it's gonna be 12 times T because I get paid monthly, remember? So 12 times T. That's this equation. All right, and you could simplify in here, write like a prettier equation. For continuously, you guys, the growth factor for continuous growth is E. So, or decay, or continuous decay. We'll still begin with our starting amount of 3,300, E to the power of, and then it's going to be the rate, 0. Why did you turn into an eraser? 0.042 times T, all right? Okay, and you guys should find, since we learned that the more you compound, the more growth you get. But we also learned that it's not by much. So if you figure out what this number to the 12th power is, it shouldn't be far off from whatever E to the 0.042 is. It should be pretty close. Okay. Oh, reflect. I'm good. All right. Okay, you guys, I'm gonna stop this.